Hello students, today's topic is the fundamental theorem of calculus. The theorem has part 1 restated and part 2. We will consider continuous functions on closed intervals, a necessary condition to apply the fundamental theorem of calculus. In this video, we will work on examples applying part 1 of the theorem. Shown on our screen is the fundamental theorem of calculus part 1, the integral from a to b of big F prime of x dx equals to big F of b minus big F of a. We will start with our example. We have a definite integral and we want to evaluate the integral from -2 to 1 of x cubed plus 1 dx. We want to compare our example with the left side of the equation. We see that a is given to us to be -2, b equals to 1, and big F prime of x is given to us to be x cubed plus 1. We will start and find the antiderivative of x cubed plus 1. The antiderivative of x cubed, we want to add a 1 to the exponent. So we will have x to the 4th and divide by 4 plus the antiderivative of 1 is x. And we want to evaluate our function from -2 to 1. According to our theorem, part 1, we want to evaluate the function first at x equals to b minus the same function evaluated at a. We will start, this is going to be equal, and we want to start by evaluating the function at b. b here equals to 1, so we will have 1 to the 4th power over 4 plus 1 and this is going to be big F of b minus the same function evaluated at a. A is given to us to be -2, so we have -2 to the 4th power over 4 plus -2 and this part is big F of a. Exactly what we have in the equation to the right side. Simplifying, we will have 1 to the 4th power is 1. 1 to any power is 1. So we will have 1/4 plus 1. -2 to the 4th power. 4 is an even number. The outcome is always going to be positive. So -2 to the 4th power is 16. Positive 16 times negative will give me -16 over 4. -2 times -1 is +2. Now we want to combine the fractions. This will give me 1/4 minus 16/4 will give me -15/4 plus 1 plus 2, I will have +3. Now I want to combine the terms and have a common denominator. I want to multiply by 4 the numerator and the denominator. This will give me -15 over 4 plus 12 over 4. -15 plus 12 is -3/4. So the definite integral is equal to -3/4. And I'm done with this example. Let's do one more example and apply the fundamental theorem of calculus part 1. We have the definite integral. We want to evaluate the integral from 0 to 4 of e to the 2x minus x dx. We compare our example to the equation shown on our screen. We see that a equals to 0, b equals to 4, and big F prime of x equals to e to the 2x minus x. We will start and find the antiderivative of this function. The antiderivative of e to the 2x is e to the 2x over 2 minus the antiderivative of x is x squared over 2, and we want to evaluate the function from 0 to 4. To do so, we want to apply the fundamental theorem of calculus part 1, which says to evaluate the function first at x equals to b minus the same function evaluated at x equals to a. So this is going to equal, first we want to evaluate at x equals to b, and b equals to 4 here. So we will have e to the 2 times 4 over 2 minus 4 squared over 2 this is going to be big F of b minus, now the same function evaluated at x equals to a. We will have e to the 2, a here equals to 0, 2 times 0 over 2 minus 0 squared over 2. This is going to be big F of a. Simplifying, e to the 2 times 4 is e to the 8 over 2 minus 4 squared is 16 over 2. E to the 2 times 0 is e to the 0, which is 1, times negative is -1/2. Any number raised to the power of 0 is just 1. Now minus 0 squared is 0. 0 to any power is 0. 0 divided by any non-zero number is 0. So this term here is 0. Simplifying, combining these two fractions and rewriting e to the 8 over 2. Combining these two fractions, -16, -1, we will have -17 over 2. Now to get an approximate answer, we can enter this into our calculator, and we will get an approximate answer of 1482. So we evaluated our definite integral and we got 1482. I hope this was helpful. See you next time.